In this example, we're again looking at geometry, but in a slightly different context. Farmer Brown's building a rectangular pen for his sheep. He has 80 feet of fencing. He's planning to build the pen with one side adjacent to a 30-foot long barn, which means he does not need to fence that side of the pen. Let's use the entirety of the barn as part of the boundary. What are the dimensions that give the largest area with this fencing? Again, let's draw a picture. There's the pen that he wants to build, and there are 30 feet along one side, say this bit right here, that this is the barn. And so that's 30 feet he does not have to fence. How should we set up variables here? There are a couple ways you could do it. One way is the following. I will call this W for the width. I'll call this part L, which means the part up here is not L, but it's 30 plus L, because I have to also include the length of the barn there. Now what I want to do is I want to maximize area, which is A is now W times 30 plus L under a certain constraint. What's the constraint here? Well, the constraint here is the 80 feet of fencing. How much fencing am I using? Well, the fencing that I'm using is the L on the bottom, the W on the left, 30 plus L on the top, and the W on the right, and that must add to 80. Which by simplifying, 2L plus 2W equals 50, L plus W equals 5, so W equals 25 minus L, so I can plug in for W here. So my area function is now 25 minus L, 30 plus L. And what's the interval here? Well, L needs to be positive. That's for sure, because it's a length over there. I can't have that be negative. And W also needs to be positive, so that means L can't be more than 25 for W to be positive. Now let's solve the calculus problem here. I can expand this out. And we take the derivative here. A prime of L is negative 5 minus 2L. Because it's everywhere, that's fine. Where does it equal 0? When it equals 0, L equals minus 2.5. That's a problem. This minus 2.5 is not in my interval. So I cannot include that point, and it's not a critical point here. So I only get my two endpoints here from my answer. And the area if I plug in 0 is 750. And the area if I plug in 25 is 0. So this is my maximum. It's not at a critical point. It's not inside the interval. It's at one of the endpoints. But that's not because the only critical point I got was outside of my valid interval where I could apply this problem. So my maximum is at 0. That is, if the pen actually just goes right to the edge of the barn and goes as far off as it can. So the dimensions I get here are length 30, just with the barn, and then width, whatever's left over, which is 25. So that's how you solve that particular problem, especially in a case where there is no critical points inside, and when a critical point falls outside of the actual interval where the problem is defined.